Let's take a look at network address translation. Originally deployed to overcome limitations in IPv4 addressing, the goal was to give us private addresses. Think of the RFC, request for comment, 1918. Address space. So this is the private addresses that we can use internally. If we just translate those to a public address as it transfers out to the internet, it allows us to basically extend the lifetime of IPv4 a bit longer. In the 90s, I don't think when they rolled this out, they thought it was going to work as well as it did. Here we are in 2020 with lots of folks using network address translation everywhere. Not a lot of folks in a rush to roll out IPv6 quite yet. We do see IPv6 in data centers. We see it used heavily in mobile deployments, and we see some companies starting to roll it out, but I see a lot of companies that are still pretty hesitant. So network address translation is still a fantastic concept to know about. Even when IPv6 is heavily deployed, I think it'll take a while before IPv4 is going to go away. So this is definitely something worthy of your time, something worthy of mastering. So remember, the goal with NAT is it's going to give us the opportunity to preserve our internal addressing plans. Well, why wouldn't you preserve them? Well, if I was using a service provider's addressing and I was unhappy with the service provider and I moved from one to another, now I'd have to change the IP addressing of all my hosts internally. By taking the global addressing and applying it to the outside of my firewall, the firewall is going to hide what's happening internally to the outside world. So two terms that we want to be familiar with, just so that the documentation makes sense. When they say inside NAT, this talks about translating addresses that are under your control. That's what most of us do most of the time. Outside NAT translates an external address. So say that I had the IP address 4.2.2.2, and I wanted you to reach it, but you don't have a gateway. So you're 10.1.1.10. And again, maybe this is a system that for security purposes, I'm not even going to give it a gateway. It can only talk to hosts on the local network. But I wanted it to be able to reach 4.2.2.2 for DNS lookups. I could say, let's take 10.1.1.2 on the inside of our network and NAT it to 4.2.2, which is the global address. So from our local workstation, we'd ping or do a DNS query to 1.1.1.2. When we do that, the firewall hears that ARP, and it goes ahead and responds. It says, yeah, I'm 10.1.1.2. When that packet comes into the firewall, it does destination NAT. So it changes the destination where it's headed. Kind of neat. This isn't what we do on a typical day. Typically, what we're doing is called inside NAT. We've got private addresses internally, and we just translate them when they go out to the internet. That way, the response can hit a global server, maybe YouTube, maybe Google, maybe eBay, and then the response can, of course, make it back to the right office. So when deploying NAT, there's some more terminology we want to be familiar with, static versus dynamic, and when to use them. So static is a permanent one-to-one mapping. You probably would have guessed that. And what we're mapping is a real IP address. That's an IP address that's actually mapped to I shouldn't use the word mapped, but configured to a host, and that host is actually using it. And then the mapped is the translated portion. So I take the real IP address of my web server, 10.50.50.80, and I map it to a public IP address. And that mapping is cool because, again, my real is going to be private in many cases. The mapped could be public. This is what it looks like to the outside world. And then when you perform a fully qualified domain name lookup through DNS, the DNS server, of course, returns the public IP. It goes, oh, here, talk to the firewall. When you get to that public IP of the firewall is going to look at its security rules, security levels, access control lists, so forth, and go, oh, you're actually trying to get to this particular target. So whenever that server initiates connections, its traffic will be translated. And of course, when traffic is initiated to the server, we'll do some translation of IP addresses as well. Again, this is very useful when we've got a device that needs to be accessible from the outside world, such as a server or service. The dynamic NAT is what we typically use when we don't care who gets what IP address. This is what we use for outbound clients. Somebody attaches to our network, they want to do a Windows update, Linux update, we'll go ahead and translate them dynamically. So in that case, again, we're doing NAT here, network address translation, not port address translation. So this would indicate that you would need a one-to-one mapping. That is to say, if you've got 50 devices internally, And it adds up quick. You've got badge readers, you've got IP cameras, you've got thermostats, you've got laptops, tablets, smartphones, etc. For all 50 internal devices, you would need 50 IP addresses from your service provider. Remember, there's a shortage of these. So they're going to charge you maybe $10 a month to use each of those IP addresses. Well, now I've got all this additional cost just to get users out to the internet. So whenever we do dynamic NAT, we tend to leverage a pool. But again, this was something we did many, many years ago because firewalls would break a lot of applications. As firewalls got smarter, we were able to use multiplexing, where we put lots of connections onto a single IP. We were able to use multiplexing much more effectively because we could look at different users internally communicating, classify them, and then share a single IP address. That's what we call NAT overload, or PAT. That's what we're talking about right here. So when they say dynamic PAT, port address translation, translates multiple real IPs. The real IPs are, in many cases, RFC 1918 addresses, but they're actually assigned to a host. A host thinks that's its real IP address. And then as those devices try to get out to the internet, we'll overload them onto a single mapped IP. A lot of times it's just the IP address of your firewall, and that IP might come from your service provider. So service provider gives your firewall an IP address, everybody on the inside just kind of piles on top of it. In the real old days, we used to call that like IP masquerading. It's just kind of changing around, appearing to be as though you're someone else than who you're really coming from. And of course, the reason we've got to do that translation is because your IP addresses internally are private. If you sent out a message into the internet with a 10 address, it should never make it back to you. It may reach the destination, it may not based on filtering, but there's no reason that 10 address would ever come back to your public IP. Static PAT is something we can do that's a little bit fancier. We can map real IP addresses and real service ports to a mapped IP and mapped service port. So let's say that I've got a firewall at my home, got an access list on it. I can poke a hole in here for different services, like remote desktop. This would be a bad idea, don't do this, but I could, and SSH, right? So I can say if somebody comes in from the outside world trying to do RDP, push them to this Windows box over here. If somebody comes in on port 22, do a translation to this Linux box over here. So you've got two separate systems internally listening on two different port numbers, 3389 for RDP and 22 for SSH, and we translate them to one IP address on the outside. So you'll get routed to basically a different internal host that's hosting a different internal service depending on what port number you hit. This is called static PAT. You may know it as the term port forwarding. Again, just talking about doing the same thing there. So policy NAT, this might have made you cringe. I hope not, but you go, oh no, policy NAT, is that going to be complex? Is that going to be intimidating or scary? I remember the first time I started working as a consultant for a company that did a lot of policy-based routing. A lot of the engineers there had tons more experience than I did. They'd use a lot of terms on phone calls and internal acronyms that I wasn't familiar with. I felt really, really out of like a fish out of water. And we were talking about PBR, using PBR left and right. And I thought, I've got to read up about this. And once I did, I go, this isn't too scary. All they're doing is using an access list to perform a routing decision, to make routing work differently than it normally would. Normally, we just use a destination IP. I go, why don't you look at the source? Why don't you look at the destination port? Why don't you even look at time of day? So policy-based routing says use access list to steer packets differently. So policy NATing, yep, you guessed it, uses access list to NAT traffic differently. Remember, when we look at ACLs, they're processed from top to bottom. You can have permits, you can have denies. A lot of times I'll have denies for things like IPsec, VPN traffic. If traffic is moving between offices in, say, Tampa and RTP, I want to make sure that all the traffic moving through the VPN tunnel is not NATed. So I'd say deny that traffic, IPsec, permit everything else. If you're going to anywhere else on the internet, go ahead and perform NAT. But the deny doesn't mean drop, it just says don't NAT. Why? Because we want to encrypt it. So policy-based NATing, just using ACLs, it means we can consider source and destination IP, source and destination port. We can look at layer 4 protocol. We can consider time of day. all while deciding how should this traffic actually be passed. Really pretty clever. So overview of the ASA NAT. There's a new NAT strategy, not that new. It's been around for a few years, but it's important to understand. And it's kind of wrapped around this concept called auto NAT. We'll get into a little bit more details as the class goes on, but realized auto NAT is recommended for most use cases. So at this point we go, okay, wait a minute. ASA has got kind of a complex NAT engine. It's not bad if we know how it works. It's all based on auto NAT, which we use most of the time. And you go, okay, well, what do I use when it's not most of the time? And I'd say you'll use what's called manual NAT. Manual is the opposite of auto, at least in car transmissions. And the manual NAT can be used before or after auto NAT. So deep breath. Most of the time, we're going to live right here. We're going to create an object like web server. We assign it an IP address like 10.50.50.80, and then I build a NAT policy right there on the object. That's object or auto NAT. Again, it makes sense most of the time. But sometimes you'll have something really specific. That's where policy-based NAT goes. Sometimes you'll have something really generic, like a catch-all. You say, hey, when you see traffic coming from any interface going to the outside, pat it to the outside interface. That makes things really simple. But we'd want to hit our simple rules last, and we'd want to hit our policies first. So if we were to do policy-based NATing, it would come up here within this NAT table. All the auto stuff goes in the middle. All the really simple generic stuff goes at the end. So when you look at it, it actually spells it out for you. Here we are with our manual NAT policies up top, our specific. Here we are in the middle with our object-based auto NAT. And then what we call manual NAT after auto, these are our really generic rules, where we say let everybody out to the internet, just pat them to the public IP. Over here, we say, oh, we'll pat these users differently based on this time of day, based on their destination network. So again, most specific up top, most generic at the bottom, and then really, this is where you'll live most of the time. You'll define objects, subnets, groups of users, things like that, and then declare how they should be NATed. If you don't want to do that on a group-by-group basis, again, we can have a generic catch-all at the bottom that's just going to catch everybody. In either scenario, everyone gets out. Just remember this order of operation, again, top to bottom. So the way that it happens, packets come in, we look at this NAT table, we read it from top to bottom, try to find a matching translation. If no translation is found, the packet is forwarded without translation. If you've been doing this for several years, you may remember the PIX, Private Internet Exchange, that predated the ASA 5500s, which predated the ASA 5500X, which predated our firepower appliances, which is what we're pretty much pushing today. They've got greater horsepower. Historically, back in the PIX days and most of the ASA era, we said it was required to have a translation. If we didn't have a way to translate that packet to hide what was going on the inside, when it moves to a less secure level, we'd actually throw the packet away. It used to be absolutely required, then it was optional, and now that feature, if you'd call it that, is deprecated. So again, just for those of you that have been doing this a while, in the old days we would drop it if a translation wasn't found. Now we forward it. Logic being we tend to move firewalls a little bit closer to the inside than we used to. They don't just sit at the perimeter or edge of our network. So that's where they decided to allow packets to flow a little bit more freely. Just good stuff to be aware of. So again, network object NAT or auto NAT is going to be the simplest NAT configuration. This is where we define a network object. It could be a host, it could be a subnet, it could be a range of IPs. And you give it a name, and then you can use it as an object in other portions of your configuration. When you define that object, you've got the ability to define your NAT policy right there at that time, making it just a really easy, clean way to do things. It's how they recommend you do things, again, the majority of the time. And then when you have exceptions to this, we can make specific rules or very generic rules that would fall outside of what we do in auto NAT.